All right, everybody. I will just start with the introductions of myself and propagation, and then we'll move on to the agenda and our esteemed guests today. Uh, I am Yash. I work at Propagation as well as my part-time job. It's not really a job. We started the project. I am an engineer at a startup called AmplifyX Labs. We deliver SaaS products to a lot of people. We do a lot of money as well. So why we started Propagation was something we wanted to do something unique. There are a lot of startups who do very traditional teaching in the sense grade 10, 12, and all that, but nobody was really teaching a lot of citizen science or astrography or astronomy or like very deep in AI. Nobody was doing that. So we thought, we and a bunch of people in our group thought that would be cool. Now, today we are here to do this project called Projects on Citizen Science. We will learn all about it. People who don't know anything about it, people who know something about it, people have some idea. We will do all that. We have two very esteemed guests today who will talk about this. Not me. I'm just here to introduce you to everybody and get you comfortable in your seats. I will start with the introductions of the esteemed professor that we have today, Dr. Gourav Banerjee. He is an observational astrographer, astronomer, I should say. I'm sorry about. Yeah, he's working as a postdoctoral fellow at the prestigious Institute of Astrophysics in Bangalore. His area of research is study of special type of stars using spectroscopy. He's also authored two books, very popular books, called Becoming an Astronomer and Mars, a Celestial Showstopper. Okay. And he has done a lot of great work. He will guide you through it all today. We will have our second guest, who is very young, very talented, Shourjya Pal. He has also written a book called Citizen Science for Juniors. He is the founder of Citizen Science Group. He has done a lot of classifying work, a lot of work in celestial bodies. He has done esteemed amount of work in citizen science. So for that, we will start with Dr. Gourav. He will begin us through the journey. He will tell us all about it. So let's begin. So please do.
Yeah, thank you, everyone. Let me share my screen first.
Yes.
I hope I am audible and my screen is also visible.
Yes, sir, you are.
Yeah, I will just keep my video off so to manage with the buffering.
Yes.
Okay. So yeah, I request others, if you have any question, you can ask. There is a parallel session after the speakers will be finishing, or we will be finishing our guidance or talks, and kindly keep your mic switched off so that, and also you can keep your, wherever you are joining from, keep your video switched off, then it will manage the buffering. So welcome on behalf of, I am from Indian Institute of Astrophysics, welcome on behalf of IIA. It is situated at Bangalore, the headquarters, although I am situated in one of their field stations, one of their observatories, which is around 200 kilometers away from this Bangalore city, inside deep forests of Nilgiri Hills in Tamil Nadu. So basically, first of all, I actually give my gratitude. I would like to share my gratitude and thanks to Propagation team. I found that this is a team of young enthusiasts who are doing good work. Thanks to Propagation team, thanks to all of you, and thanks to SS Citizen Science Group for initiating this kind of workshop or initiating this particular webinar system or symposium type of workshop. I feel that this is the right time. This is a very important time where this kind of workshop should be organized more and more, maybe in future in some more advanced level also. However, this can be an introductory session where we can talk about why this subject of astronomy and astrophysics is gradually gaining more and more importance, visibility, and it is also catching the attention of common people, even young students more and more. And if anyone wants to contribute in this particular field, is this subject only for high-level professional astronomers, or at least up to a certain level, anyone who is interested in astronomy, astrophysics can also contribute. So that is the main motto of this particular workshop. And based on that, we have designed our talks, and we will try to give a glimpse of what is the importance of astronomy and why, see, what is citizen science, how one can contribute as a citizen of the world, devoid of any country, any religion, anything else. If you want to contribute to astronomy and astrophysics, how can you contribute? So let's start our journey. But before start going to these main points, see, I would like to say that astronomy presently is for everyone. It can be considered as an everybody's science or everybody's subject. Why I am telling this? This is the thing which I would like to talk in my session, and followed by another session which will be taken by one of my wonderful person, one of the most wonderful citizen scientists from India, that is Shourjya, who is himself a school student. So he will be basically providing most probably a guidance how one can contribute through particular few citizen science projects. So this astronomy has a long route. It's a very, very long route. And maybe if you go to very ancient periods when there was no documentation of anything, means pre-documentation era, pre-calendar era, even from those very ancient days, people might have been watching the sky. And that is mostly because human beings, this Homo sapiens, human beings have a very natural instinct, which is basically not present in case of any other animals. And that is natural curiosity. We are curious. So most probably this natural curiosity drove human beings to look at the sky like this. However, during these times, you can understand, now we can feel, looking at the sky, people didn't understand what are these objects, what is suddenly happening here, what are these five faint patches of light. Nothing were understandable. But gradually, as we see now, we see in our own world now that there are some people who are high level intellectuals, they are brilliant, they are excellent. So during those days also, there were people who were more matured than others. There were intellectuals. We might not know their names. So through years, through months, through decades of observing the sky in a serious manner, having nothing in their hand, no instrument, almost no tools, no science, no technology, but just by watching the sky in some thinkable way, in some rational way, which we call as observation, through naked eye. So just observing the sky years after years, people were understanding, or people gradually understood, that this whole night sky, this sky is not meaningless. It has some meaning. It can tell us something if we observe these objects. Presently, we know most of these objects we can see here in this night sky are stars. We also see some planets, sometimes comets, sometimes some other object, moon. In the morning, we see sun. Now, all these objects put together in the night sky and in morning sky having sun, they tell us something. And what they are trying to tell us is about how we can progress, and become gradually more and more civilized. This is a very long journey. Humanity's civilization, humanity's development has extremely huge benefits taken from astronomy and space science. We owe a lot to the sky, we owe a lot to astronomy. So few people gradually, years of observing these night sky objects, they gradually understood that there are some bright spots or bright stars in this night sky. Well, that time there was no concept of star, but as of now, we can consider that. So there are some stars which are brighter in this particular silhouette of the sky, and some are fainter. Now, what was the basic consideration? If we can make some recognizable patterns joining imaginary lines using the bright stars, then there will be somehow we will be able to recognize which particular pattern we can see at what time. So what the people of those ancient prehistoric days were trying to do is, there was no timekeeping device, there was no clock, no compass, nothing. Can this night sky serve as the first timekeeping device? Can this night sky become the clock for the human beings? And this was made possible by this process of understanding the night sky and joining some particular patterns in the night sky, forming some imaginary patterns. These patterns we call nowadays as constellations. You see in this silhouette of the sky, this is how ancient people made two particular patterns joining some of the bright stars in this region. Now, one can obviously question, okay, for me, these are not looking as bright. For me, this is looking bright, or this is looking bright. That is absolutely up to you, because as I am telling, these are imaginary patterns. This is the famous Saptarshi Mandal, or Arsa, the Big Dipper of the Ursa Major constellation. And the first two stars of this Saptarshi Mandal points towards a very special star, which is Polaris. Means if you project this line for around 5 times. So this Polaris, or the North Pole star, will always remain almost fixed, at least in one person's average lifetime, at the exact North Pole. So gradually, what I am trying to say is this concept of constellations, basically joining some bright stars in the sky and forming a recognizable pattern. That pattern can be a figure of a human being, or some animals, or some daily used items. Like this, if we can divide the whole sky into recognizable patterns, these patterns were imaginary, but till now we follow these patterns, which are known as constellations, to understand, basically to understand, to recognize the night sky. And how these patterns help us? There are presently, the whole sky is divided into 88 such constellations. Suppose if we come to definitely the winter sky is the best time to watch the sky for any amateur astronomer, astronomy lovers. They do camps and sky watching sessions mostly in the winter time, because winter sky is fascinating, and it is rains and all these things, it will be devoid of them. So sky, the clear visibility of sky will be, probability is more. See, if I come to the winter sky, how that winter sky is divided into such constellations and patterns, this is how. So this is the winter sky, which we can see basically from our Indian soil. And as we can now see that winter sky is divided into some patterns, some constellations. However, this tells us that this is not only fascinating that we will recognize these patterns, we will be able to identify constellations. It will also tell us that this is the sky when winter is going on. This is the time when winter is approaching, or winter is gradually going away. That means the sky became the first calendar for human beings. And that actually helped humanity to progress. In the first point, when they didn't have anything in their hand, nothing, no science, no technology, no, not even a calendar, not even a clock, not even a compass. So this night sky was the first definite friend of humanity, which helped them to progress. Navigation, agriculture, when to do some particular type of agriculture, when to understand what particular season will approach. All these things now we can very easily understand. But think about a world, if you are situated 3,000, 4,000, 5,000 years ago, who were helping us? This night sky. So this is the winter sky, and some of you who are interested in night sky watching definitely can recognize some of the patterns. If I show you the pictures, obviously it will be more recognizable. You see, this is the famous Orion constellation, the Kal Purush, the Hunter, and all these known constellations, the Andromeda, our nearby galaxy, Andromeda galaxy, is situated in this particular constellation. So you can read about it, you can see the night sky, you can gradually see how we can recognize those patterns, and remember what type of sky will tell us about so many things, about the seasons, about the time, about the time of at what time you are watching, from what kind of latitude. Everything we can get from just by recognizing these patterns. But however, now, without going to details of the history, how this development happened in astronomy, it's a very long and exciting journey. I would suggest anyone interested in astronomy, please go through some good history of astronomy, good books or good documentation, internet sources, authentic internet sources, definitely. See, it is very fascinating. I would gradually try to shift to today, without that is not the focus of our part today. So from those days, 3,000 years ago, when this was the only calendar for us, we have progressed a lot, taking the help of astronomy and taking the help of science, modern science, technology. From those days, we have come to a day like this. So presently, actually today, I am talking to you people sitting in this place, which is known as the Vainu Bappu Observatory. It is one of the most important astronomical observatory of Asia, which is under Indian Institute of Astrophysics. So I am placed here. So I am speaking with you sitting somewhere nearby this place, this place. So where we are having our guest house. So you can see that this is a place, as I was telling, it is an observatory run by Indian Institute of Astrophysics, and it is definitely the most important astronomical observatory in India. It is situated in Tamil Nadu in a place known as Kavalur, a very small village nearby known as Kavalur. This is the Kavalur village. It's fully inside Nilgiri forests, at the top of some Nilgiri hills, devoid of light pollution, basically devoid of any kind of dust pollution. It's a wonderful place to see the sky. So think about those days 3000 years ago when only naked eye observation, naked eye watching of stars helped us to understand how we should live safely. From that day onwards, if we come to this day, we have excellent telescopes. These are all telescopes. So discovery of telescopes ushered the age of modern astronomy. And when Galileo Galilei first used his telescope to see the sky in 1609, it is regarded as the time when from modern astronomy and modern science took birth. So from that, those days are gone. Now we have come to a very long time. If we come to this observatory, anyone who is a student, who is an astronomer, who is doing some academic work, and anybody from India, if you want to visit this observatory, you can, definitely you can visit. You can go to the IIA website and check the details from the observatory, and you can send a mail with some academic purpose. You can definitely visit the observatory. This observatory has so many telescopes. It has huge history. One can go to this article to read about this observatory. So let us come to what type of telescopes we now use for astronomical researches. You see, in this observatory, this is the largest telescope facility which we have. So this is the telescope from in a front view, aerial front view. You see, this is a huge telescope. You see, this is a 6-storied building, and at the top of that, the telescope is situated. It is looking small because it's an aerial view. Just to give a perspective, see, the diameter of the mirror of this telescope is 93 inches, at around 8 feet. So in front of this telescope, with its all components and back-end instruments, you see people are standing nearby. So I guess now you can understand. Now you can feel the sheer size, the sheer technological advancements which has happened. Now we use this kind of telescopes from the ground, and much more better also, to study the sky. And we all know that we have a certain good number of telescopes, satellites, spacecrafts, International Space Station, which are outside our Earth's atmosphere also. So with this tool of it is this arsenal of technological advancement, tools, sophisticated instrumentation, we are able to understand so many things about astronomy and astrophysics. And as technology is advancing, our knowledge about astronomy definitely is increasing, and it is also increasing in a way that why we should more and more focus in astronomical research. We are also realizing that. I would like to come to that part. Before that, I would also like to highlight that, see, my friends, we have to understand, I am from IIA, so this is not only India has only IIA and Vainu Bappu Observatory. Apart from IIA, Vainu Bappu Observatory, we also have fantastic observatories, excellent facilities for doing astronomy from India. That is, these are all mainly professional astronomy. So likewise, if we go to Nainital, Uttarakhand, you see there is a hill just before entering Nainital. This is known as Manora Peak. So this Manora Peak is actually occupied by Department of Science and Technology under Government of India, and they have set up a proper good research institute known as ARIES, Aryabhatta Research Institute of Observational Sciences. This is also one of the very good top-level astronomy research organization or institute in India. Likewise, we have to remember that astronomy is one of the very important subjects for any developed or developing country in the world now. We have learned a lot about astronomy within these past 3,000, 4,000 years, but still we need to know more. If I want to go to that area, how anybody can contribute in astronomy, first let us concentrate why we should study astronomy. We know so much about space, outer space. We know about our solar system. We know about the sun, our own Earth. We know how galaxies collide, how supernova happens. And we have even found out gravitational waves, the supermassive black hole sitting inside our own galaxy. So much knowledge we already have. Is it important to invest money? Is it important to go on studying astronomy nowadays also? Why it is important? Yes, my friends, it is extremely important. And these are some of the highlighting points which I have highlighted. First of all, astronomy is the greatest natural laboratory which provides us 100% original, authentic knowledge how nature works. The sheer volume of universe, it is so huge, so variety type of objects are present and phenomena are happening in such shearing scales. That kind of phenomena, it cannot happen in earthly scale. So to test whether the understanding of science which we are receiving, whether the physics which we know, the chemistry, the mathematics which we have understood, whether those laws of physics, mathematics, chemistry, biology, they are valid only inside our Earth or across the universe, across the solar system, our galaxy. How will we test that? We have to study astronomy for that. How nature works actually, astronomy can give the exact and the most detailed idea about that. As I have told, because it is the most extreme laboratory, you cannot make such a natural laboratory in our earthly condition. So basically, if you see the most profound application of scientific knowledge, we can apply and learn in case of astronomy only. And these things help us to make our own lives comfortable. This is very difficult to understand. I will come showing an example. So overall, astronomy is not only a fascinating game, a fascinating drive for some fascinating people or mad people like me or someone else who is interested in astronomy, and professional astronomers who are sitting at night in the jungle and using crores of rupees of telescopes and seeing the stars doing something, galaxies doing something. It has something to do very, very important with everybody's life in the world. It is to know about ourselves, to know about our home, our existence, our origin, and to make our life comfortable, to make our only little home, Earth, safe. For existence safely, for our own existence safely in this Earth, we have to study astronomy. There is no other way, my friends. Now, why I am telling these things? Let me give an example. I have told that outer space is the most extreme laboratory, right? Well, take this example of the nearest star. This is our sun during the sunset or sunrise time, whatever it is. So when we see at the sun, we don't feel that it is a burning ball of gas. But if you see the sun using some very sophisticated X-ray telescope system, then sun reveals its actual glory. It is a dangerous burning ball of gas. It is situated very far away from us, and it is extremely big every moment. Such kind of solar flares, basically such kind of flares of burning plasma gas, extremely hot, these are coming out of sun. So if you take the picture of any of such solar flare, burning ball of plasma and material, if you take a picture of this, such any kind of this particular solar flare, if we take a picture and if we show it in a zoomed way, this is how the picture looks like. One burning ball, huge burning ball sun, and one solar flare coming out from that. And if we put our Earth in front of, so this is how big our sun is. we have to understand, we have to remember, my friends, not
I think your voice is getting stuck, sir. You're not audible right now.
So you are not audible. Thank you.
It might be the internet connection or something, sir. You're not audible still. There seems to be something wrong with sir's connection. Uh, we'll wait just a second to give him the time. There might be some sort of internet glitch or something like that.
It's okay. We will wait.
Yeah. Fine. Okay, there's some doubt in the chat. Till then, okay, got interrupted because of the internet. Till then, I'll tell you something about the propagation group. All right. I know this is the middle of it, and some very important stuff got cut off. But I think Sir is facing some internet issues, some great amount of internet issues. I'll tell you something about the things that we're about to do in propagation. I think it might be all right because I think in the back end we are trying to figure out what issues Sir has got. It's just a network issue, it turns out. I'll tell you about the propagation thing that we are doing. All right. There'll be a lot of webinars related to AI, related to citizen science, related to space, related to astronomy, and all that stuff. People who are interested in very niche things, want to make careers in very, very niche stuff, we will give out projects where you'll have to submit your code using your GitHub links. All that stuff is going on in the backend. There are people who are testing out the projects that we are doing. There are people who are testing out the courses that we are making. There are student trials that are going on. It will be available to you in very, very soon in the propagation app itself, the web app that we are building. Till then, till Sir joins, I would request you all to join the WhatsApp as well. Sir has, I think, joined back. Is your connection all right, sir?
So, yeah, since I'm joining from the jungle, so sometimes this happens. Okay,
no problem.
I will again start from maybe from particularly this slide.
Yes.
Yeah. So yeah, as I was telling that, yes, this is the example which shows us that why we should study astronomy, why we should, because astronomy is producing us, giving us the largest laboratory, the most extreme laboratory to learn about nature. And what we get by studying astronomy, this I can explain, I feel, by giving a very best example is Apollo, journey of man to moon. Now, many people can ask this question to us, to all of you, if you are doing astronomy, okay, what happened? What we normal people got just by sending man to moon by Apollo? It was just a wastage of money, resources, or every human being has got something? Yes, my friends, it was not a wastage of money. There is a huge list. Even I can give a complete talk how much only Apollo missions have helped each and every human being in this earth. But that time is not there. I'm just giving a snippets. How many of you know that the water purifier which we use today almost in every city house, that water purification process development happened not for us basically, but for these people, Neil Armstrong's team, for sending them to moon. So a modern water purification system which almost every one of us use in our homes, in institutes, in any city people. This water purifier came from Apollo mission. Pacemakers, so many people have been saved by pacemakers, and specifically programmable pacemakers. See, in medical science, you see pacemakers, gas analysis, anesthetics, memory foam, kidney dialysis machine, anti-glare filters, and more high quality lenses and glasses, and anti-glare screens. So many things have come because of Apollo missions. We all know about deep freeze system in our refrigerators. Proper deep freeze system in refrigerator was also a boon which came from Apollo. We have modern good house insulation systems. That house insulation system was also developed from Apollo missions. So you can get so many details about these Apollo missions, how Apollo missions have helped us. You can also get details if you go through, read enough, how ISRO missions are helping Indians. So there are lots of huge list. I am just giving a glimpse of it. Yes, my friends, what I am telling, what I am claiming is absolutely true. Whether you believe it or not, astronomy is an abstract science, but doing that abstract science makes our lives comfortable. Every person in this world at present owe to astronomy. And definitely, after learning so much about astronomy for so many years, there is a huge mystery. We only can see 5% of the universe. The rest, 95% of the universe, whatever we see, whatever we can see, we can study, we can understand, basically comprises only 5% of the matter or universe. The rest, 95%, consists of two very unknowingly mysterious entities. One is dark energy, one is dark matter, about which we don't know anything. So after knowing so much, if we claim that we know so much about astronomy, about universe, we have gained a lot by studying astronomy. And that is also, we can see 5% of the universe today. Think about the rest 95%, which we cannot see, which we don't understand. Somebody has rightly said that during this time, your future will be bright if you can study the dark universe. So I guess we can feel at this point of time that astronomy, knowledge about astronomy, as it increases day by day, it can give us so many more comfort, so much of more interesting discoveries, which we can use for making our lives safe, our lives comfortable. And also, as days are passing by, this knowledge is increasing, but there is an issue. How many astronomers are there in total in the world? That is very less. Professional astronomers are very less. So in India also, if you see day by day, major research institutes, universities, they are coming up gradually. These are some of the very well-known research institutes, top-level research institutes in India where astronomy research is done. So anyone who wants to go to this professional astronomy field, become an astronomy researcher, you can definitely look into these institutes. But if there are people, there are students who want to contribute to astronomy, not being a professional, that possibility is also there nowadays. And that possibility is known as citizen science. Citizen science is a concept. It is basically not a single project. It is basically a concept. It is basically the name of a concept, and that concept tells us contributing in professional astronomy by anyone or by any citizen of India and abroad, basically by anyone of the world. So how can anyone contribute in astronomy? For that, the citizen science projects or citizen science concept was developed. Now, before going to what citizen science tells us, how to do citizen science, yes, we have to remember astronomy is one of the very few subjects in the world where an amateur person can really contribute. You see these names, I have just given some very few names in one slide. They were not professional astronomers. I hope Galileo, Copernicus, William Herschel, at least these three names everybody will recognize. All the others are also greats. So basically, they were not professional astronomers. They were all amateur astronomers. So they have changed. Basically, we can say that their works have changed not only astronomy, but also modern science. So astronomy is among the very few subjects where an amateur person, if you have interest and seriousness, you can definitely contribute. Now, how? Well, let us give an example. We see stars in the sky, and friends of all age, I will tell you, most of the stars in the sky are variable stars. They vary in brightness, in intensity. I'm not going to the details of this physics any. So due to various reasons, we see stars varying. So this star is the famous pole star. Even our pole star is a variable star. You see, for within some years, sometime you take the picture of a pole star, after a few years you take the same picture, you will see the pole star's brightness is either decreasing or increasing. There are so many certain reasons why stars are variable, but it is very important to study such kind of stars, variable stars. So there can be stars which are rotated, double stars, multiple stars revolving around a common center of mass. And as you see this particular star coming in front of another, you will see variability happening in brightness. There can be explosions of stars, there can be pulsations of stars, so many aspects are present. So basically what I am trying to tell is maximum of the stars in the universe, they are variable stars. And it is very important to study variable stars because study of variable stars provide information about properties and evolution of stars. They can also answer some questions which we cannot answer in any other way. So systematic observation of variable stars over decades, over years, over months, it is important to understand how their variability is happening and how that variability tells us about the universe. If you see these three examples, some greatest discoveries, some greatest revelations in the history of astronomy or space science has happened by studying variable stars. So there are type of variable stars. I will not go to details. These are known as Cepheid variables. By studying these variable stars, it was first discovered that our universe is expanding. The expansion of the universe, and as a result, the birth of cosmology subject, the whole cosmology subject, basically was made by studying variable stars. If you want to know how our sun, a sun-like star, will evolve in future, we have to study a type of variable known as Mira variables. Sometimes very massive stars definitely burst away, explodes at the time of their death, which we call a supernova. So studying a particular type of supernova, scientists were able to discover that this expansion of the universe which is happening is not happening at a constant rate. Our universe is accelerating. It is becoming bigger and bigger at an accelerating speed every moment. So expansion of the universe, acceleration of the universe, both were discovered by studying variable stars. Even our sun's future, properties of stars, evolution of stars, we can study, we can understand in details by studying variable stars. But the question is, that's why we need people to study variable stars. How many people are there? How many professional scientists or astronomers are there who can absolutely focus 100% on studying variable stars? That is less. That is very less. And there comes this concept of amateur astronomers or any citizen of the world. You can contribute in variable star observation. So once I was also a member of this consortium. It is known as American Association of Variable Star Observers. Anyone can go to this website and you can create your own profile and you can analyze the behavior of variable star data, which will be given here, or you can yourself schedule observations. And after observing a variable star, if you have telescope or some other aids, if you don't have, then also you can study the behavior of already observed variable stars. And if you want to observe any variable star, take the data and submit that data to make this database more and more greater and larger. you can help in that way also. So what you are contributing, either you are studying the nature of variable stars, or you are observing some variable star and contributing that data to this database. Basically, you are making this database more and more rich, more and more powerful, so that the professional astronomers can actually study the data, analyze the data professionally, and we can understand how stars evolve in much better way, in much finer way. So this is one example how a general citizen science scientist, which we call, or anybody who is interested in astronomy, can help in contributing in astronomy research. So this is how these citizen scientists came. Even the I would like to, it is our pride, so I cannot just forget this name. One of the greatest variable star observers in the history of the world is a Bengali from Jashore, basically from Bengal province. He died in Barasat, Calcutta. See this name, he is almost an unknown amateur astronomer, didn't receive any recognition. It's unfortunate to say, didn't receive any recognition from India, but is extremely well known in the world community of variable stars. Even if you go to this APSO, American Association of Variable Star Observers, you will see a complete whole room which is dedicated to the observations done by this person, who was basically a peon. He didn't have money, but in his whole lifetime of more than 50 years of doing pioneering observational work, he has submitted 37,215 correct observations to Harvard College Observatory. So as a result, he has received extreme amount of honors, highest honor from France, highest honor even from Harvard University. But unfortunately, till now, many people in India don't know this great name. Harvard College Observatory presented one 6-inch telescope to this person, which is this telescope. And with this telescope also, he carried out observations, more than 20,000 observations he carried out with this telescope. If anyone wants to see this, one of the most historical telescopes of India, this is this 6-inch telescope, you have to come to our observatory. It is still now kept in our observatory. This telescope was handed over to the founder director of Vainu Bappu Observatory, who was another great astronomer, Vainu Bappu. And presently, we have converted this particular telescope to a solar telescope. Anybody can come and see the great telescope used by a great person, and one of the greatest contributor in variable star research in the history of humanity till now. Well, now I will come to this actual platform. If you are interested that I also want to contribute in citizen science, how I can contribute, one easy way is you go to this website, zooniverse.org. Zooniverse is a platform for all amateur projects, amateur people driven projects, or projects where amateurs can contribute. So it's a single online platform where all people powered projects are there, or all citizen science projects have been accumulated at the most possible way. So you see, if you go to this universe, you will not only see astronomy related projects, you can also see nowadays citizen science related projects are available almost in every type of area: language, literature, medicine, nature, social science, everywhere. Just go down, scroll down, you will see space. So presently, I was just checking a few minutes ago, presently there are 31 astronomy related projects which are active. So you can actually join any one of them. You need not have to have any specialized background, training, expertise, no nationality, no religion, no boundary is there. Only thing you require is some interest. No knowledge is also required. There are wonderful tutorials. Whatever project you select, you will get a tutorial first to understand what you have to do, how you can do, and then you can start contributing. If you are interested in variable star research, you can definitely search some project from here, or obviously you can join APSO. Likewise, you can contribute. And yes, for example, I would like to show one such project. This is a citizen science project under Zooniverse platform. What is this? Disk detective. So what if you are becoming a member, if you are joining this particular project, what you will be doing, you will help in finding, in discovering, in spotting astrophysical disks around nearby stars, basically nearby young stars where planets are forming. So any hot planet forming star, any hot star, yeah. So you can just switch off. Yeah, thank you. So any planet forming hot star, they will, a solar system, planets, they are formed from a hot, extremely huge protoplanetary disks. It is very difficult to detect such disks. So we need the help of amateur astronomers. We need the help of citizens of the world. So this detective is basically that the data is coming from a particular mission. This is known as WISE mission from NASA. It is a space satellite. It's a whole sky survey in the infrared regime to detect dusty disks around young stars. Now, if you are helping in searching and finding such disks around young stars, what we can do, we will be able to, the professional astronomers will be able to analyze that data and tell us how our solar system formed. So basically, citizens scientists will be helping or assisting professional astronomers to detect dusty debris disks, and which ultimately can tell us through intense analysis how our solar systems formed, how other solar systems form. So basically, this is a way by which you can contribute. Anybody can contribute in astronomy up to a certain level by joining citizen science projects. If I want to come to this particular project, I would like to show you. Let me go to the internet. See, if you go to this Zooniverse platform, this is how its Zooniverse platform looks like. This is the home page. You go to click this, explore projects. Now I come to that same place where I was showing this. When I was showing my screen, a slide. Scroll down and come to space if you are interested in astronomy. Click here. I was telling, right? You see, there are total 31 active projects on astronomy. These are the projects. So you can go to these projects. These are the projects which are active. Any of the projects you can go click to check whether how you can contribute. So you see, now you are watching this thing, this detective. It is still now active. So basically, I also professionally study stellar disks. So I am more interested into this disk detective project. Once before becoming a professional astronomy researcher, I was also a contributor to this project. So what you can do, you can go here, you can click this button, learn more, and you see they will give you all details, all what you need just to start this project. So who is the team member? What are the questions? Basically, many questions you will have before starting, and see the results. If you see the results, you will see that using the data, using the help from or the contribution from amateur astronomers, so many top level research papers are getting published, and that is increasing day by day. So using only disk detective project, so many top level research papers have been published. So many. So we can understand and see there are many people among these whom we recognize that they are not officially professional astronomers. If I come back to the slide, I can show you there are people who are basically amateur astronomers. You see this particular paper, which has been published in a journal known as the Astrophysical Journal. It is one of the topmost journal in astronomy. So all these authors who are mentioned as number 6, what is their designation? They are disk detective citizen scientists. They are amateur astronomers. So you see this name, basically one of this name, Hugo Luca. He is one amateur astronomer who is a group member of this SS Citizen Science group also. So basically, if you're contributing immensely, if you're doing some meaningful contribution, you can also see your name as a co-author in an absolute wonderful, authentic research paper, obviously, also. Definitely we'll get certificates and all these things that will come. But if your contribution is really meaningful, then the scientists or astronomers do not hesitate to give you a co-authorship in a paper also. That's why I wanted to show this. So apart from that, yeah, if we go ahead, just to give another glimpse, you see, you can go to this website. How many number of published research papers have been produced by citizen science projects done by NASA? All the citizen science projects developed by NASA, it has produced a whole lot number of, huge number of published papers. You can go to this website, you can go to these publications, click here and just scroll down and you will see whole lot number of papers. So that is a great inspiration, I guess, for anybody who want to contribute, being a, maybe being a non-professional also. In India, is there any citizen science project in astronomy? Basically, in India, the first citizen science project which was developed by a wonderful person known as Professor Dr. Anand Dota. He's a professor. He's also an eminent astronomer from India. So the first citizen science project of India was based on radio astronomy. It is an astronomy-based project. This project is known as RAD at Home, Radio Astronomy at Home. However, this project you can join, you can go to this Facebook page, you can join, just search RAD at Home at India in Google, you will get it. This is their website. If you are a graduation student, basically, since it is dealing with some technical point, radio astronomy, this is not for everybody. If you are a BSc or BTech student, you can join this project and contribute. However, if you are not a BSc or BTech project student, then also you can, if you want to contribute, you can contribute in another project. This is another project, 1 million galaxies, which is a citizen science project in astronomy developed by Indian Institute of Astrophysics in collaboration with another great wonderful organization from Pune Knowledge Cluster, PKC. So what if you are joining this project, this is the website, you will get a homepage like this. Just get started, sign up and get started. Everything is there. So what you can do is, you will be helping us to find some particular features which are present in galaxy images. And all these galaxy images are taken from a very wonderful, great 8.2 meter class telescope system, which is known as Subaru. So I'm just going through very fast since we have a time limitation. You can just go through details in details. I'm just giving you as much information as I can give so that you will not forget. You have a lot of information now. Now, there are some other aspects. Without searching galaxies or stars, you can also contribute in searching asteroids. You see, this is the asteroid belt. This is an animatic picture. The real picture, almost the real picture looks like this. So if you see this picture, all these green and red dots and blue dots basically are discovered asteroids, and all are between Earth and Jupiter, mainly in the asteroid belt. But some of them, you see, this is the sun, the third orbit is Earth's orbit, and if you very carefully look, you will find that some asteroids are crossing Earth's orbit. What will happen if that asteroid, if an undiscovered asteroid suddenly hits Earth, it will be a catastrophe. If you want to see such kind of catastrophe in our own country, just go to Maharashtra. In a place, in a district known as Buldana, you will find a crater like this. It's around 1.8 kilometer in diameter, around 500 meters deep. What happened? Around 5 lakh to 6 lakh years ago, maybe a 10 or 20 feet rock from space came and hit this place. Just imagine a 10 or 20 feet rock hitting this place and creating such a huge crater, around 2 kilometers radius, and it was a catastrophe. So such kind of dangers have come to Earth so many times. So it can also create devastation. It can also create complete devastation and loss of life, even mass extinction. And I feel many of you know that dinosaurs got extinct due to such a type of catastrophe. An asteroid, maybe of the size of few kilometers, maybe 10 kilometers or 8 kilometers, suddenly hit Earth one day around 6.5 crore years ago, and thus creating a massive catastrophe all around the world, destroying dinosaurs, destroying almost 70% of life. What will happen if an undiscovered asteroid suddenly hits our Earth today? It can happen, and it can again create such catastrophe. Whatever we believe, God or astrology or whatever you people believe, nothing can save us. Only one way we can save our home Earth. That is by studying more and more and more about astronomy. So that is why this project has been developed. It is an international astronomical research collaboration where people from any part of the world without any barrier can asteroids, so that professional scientists, astronomers can characterize them, understand their trajectory, and we need to discover any asteroid, any single asteroid which is present near our home, because otherwise we are in danger. So this project is also a wonderful citizen science project. Many people are contributing meaningfully in searching asteroids and thus helping our understanding, our knowledge to grow about unknown asteroids, about the threats coming from unknown asteroids. So from India, the first people who discovered asteroids who were not professional astronomers were basically two school-going boys, class 11 boys from Delhi Public School in 2011. You can go to this particular news or you can just search, so you'll get it. Now this has become more and more prominent. Many Indians are also looking into asteroids. And if you want to take some help, I have told so many things within maybe 40 minutes. I will just stop another after 2-3 minutes. So basically, if you want to take some help, is there any group, is there any WhatsApp group where you can join, which is a WhatsApp group devoted to citizen scientists? Yes, such a group presently exists in India. I have given the details here. The group is known as SA Citizen Science Group, and you can become a member of this group. Nothing you don't need anything. Only one thing you need is interest in astronomy. So you can just WhatsApp this number. It belongs to Mr. Shobhan Acharya, who is the founder of this group, a wonderful person, a highly contributor, a great contributor in citizen science projects from India. And definitely you can give a reference that I am from this workshop. I would like to become a member and I would like to contribute. So this group presently is a large group, the largest citizen science group in India, which deals mainly with astronomy projects. It has more than 3,000 volunteers, I believe, in almost every state of India and even abroad, from many countries. There are more than 300 members in this group, again, across the country and abroad also. And they basically guide in more than 20 astronomy related projects which are going on across the world. So if you want to join any such project and need some help, you can definitely become a member of this group, a group member, and join such a project and contribute. Or you are doing it alone and need some help, you can put your queries. There are definitely experts who will answer your questions. So I will just show you using such technique. So this group was basically formed in 2021, and see the success which has started coming within these 3-4 years. So basically, this boy is Arush from Calcutta. At the time of 2023, when this newspaper article came, he was the youngest citizen scientist of NASA, under NASA. Under NASA, how many citizen scientists are there in the world? He is the youngest citizen scientist. And he has helped in discovering 5 asteroid candidates. So he was reading in class 5 at that time. Now he is in class 7. So you can understand class 4 or 5. So at 9 or 10 years old, a 9-year-old boy can help in finding 5 objects which might be asteroids. So it is for motivation. So anyone can do that. I will also like to show this picture. He is our next speaker, Shourjya. So he was also a young boy who was doing this. And he is not from, you should not believe, you should not think that I can only contribute if I am belonging from a big city. This boy is from Malda. Uttar Bango. So wonderful contribution he also given. He will explain his contributions himself. Shourjya. And it is also not about gender. You see, this girl, Vidisha, maybe from class 4 or 5, you can see. So like this, you see all these names who have contributed in such particular international astro research collaboration, maybe sometime, at some particular time from across India, and they all got this motivation after becoming a group member and gradually moved on. Many of them are doing their work till now in a better level. So doing this, even you see top level papers can come, top level publications can come, who have actually acknowledged, who have given co-authorship to the members of this group who go, and even Shobhanacharya. I guess Shobhanji is also present today in this workshop. This is a motivating factor for not only youngsters, even for us like professional astronomers. He's a motivating person for all of us. He's really doing a good job. Now, if you all want to join this project, please come forward. And thanks to all of you. Thanks for your patience. Thank you.
Thank you, sir. Thank you so much. This was a lot of great information. I am personally from a tech background, so I loved it a lot. This was fascinating. I absolutely wanted to see all of
Thank you.
this.
Thank you.
Yes.
So I'm stopping my screen as of now. Yeah.
I'll just, there are a few doubts that people have. I'll just ask them to you so that you can just clear them out. Yogesh Malviya asks, is there a way to know what we can calculate or how big the universe is and what is happening at the edge of the universe? It's quite like.
So will they ask the talks now, or will we can take it after Shourjya's talk is over? What?
Yeah, I think we should take it at the end because this is like a very different kind of question than we talked about right now, than the topics that we covered. Will that be fine? Sir?
Okay.
I think
Okay.
you
So I guess since there is some internet issue, can we take these doubts after Shourjya's talk? Maybe internet will be
Yeah.
better.
Yes, sir. Yes. We can
If
do
that
it
is
till then.
possible.
Yeah, we have a few doubts. We'll take them at the end. Uh, I'll tell you a few instructions about it. Please join the WhatsApp community that we have for propagation. That way, you will get all the notes of today's meetings. You will get everything, all the PPTs that Shar has shared, all the PPT that Sauraj will share because he's our next speaker. There'll be a lot of info in that WhatsApp group. There'll be a lot of new opportunities in that WhatsApp group. So please do join it. There'll be a link right there. We will now move on to our next speaker, who is the very young, very talented Shourjya Pal. He has done a lot of work, like Sir explained. He is a very motivating figure. Let's start with him, and then we will have some instructions about you doing a lot of work that can be helpful to you, and some people who have great amount of doubts will also solve that. Let's move on to Sauraj.
Yeah, good evening, everyone. Please give me a moment to share my screen and I will start. Yeah, please let me know
Sorry
that
for the
is it.
internet.
Yeah, is
Sorry,
my
we can
screen
take the
visible, sir?
queries after Shourjya is over. Yeah, it is visible, Shourjya. Go ahead.
Okay, sir. Okay, sir. Thank you. So, good evening, everyone, and it's my honor to speak as a guest speaker in such a webinar arranged by Propagation, and I want to pay my warmest regards to Jitendra sir from Propagation side and Shobhan sir from SS Citizen Science Group who has organized this project. And also, I want to share my respect and honor to Gaurav sir because it's my means privilege to speak as a guest speaker along with him. And you know, being a class 9 student, I learn many things, means lot of informations and lot of concepts I get from his speakings. So starting today's topic, you know, our topic is today's citizen science. So actually, as Gaurav sir has reflected some light upon this concept. So I'm starting that uh, what is the need of citizen science? Means these projects are there, means there should be any particular reason for these projects to be originated. So basically, you see, there are many telescopes in the large telescopes which are placed in our Earth's crust and outside our Earth's crust, maybe. Means it, like the Hubble Space Telescope and the James Webb Space Telescope. And recently, in the Chile, we have the current largest telescope in the world, that is the Rubin Observatory, Verasi Rubin Observatory. So means in a day and in means moments, we are getting lots and lots of slides and captures images from those telescopes. And so the amount of images that are coming to the scientists, professionals, means you think, is it sufficient for the scientists those who are working in a lab in NASA or in ISRO or say ESA or any other professional organizations means to look into? See, because means there are vast means lot of means slides, and the number of scientists are limited. So we can't just means make all the means persons citizens in the world and give them the degree professionals of the scientists, and they can work in as a scientist, because we also need other professions, right? We also need doctors, we also need teachers, we also need professors. And up means above the age of 18 or 20 or 22, we can't get the means professional degree to work as a scientist. So here the function of citizen science and citizen scientist comes. The main role of the citizen scientists is to look into the slides that are captured from the several large telescopes of the world, and to classify or means look into the slides, and by the means criteria given by the professionals, they need to means we need basically to means classify the slides and look into the slides, and we can help them, we can help the real astronomers in real detections by giving the preliminary stages of research we can do. And today we are talking about space, means space is a vast background, but it is not that the citizen science project is only I means confined to a topic space. Means it is a vast project. Means citizen science project is a vast field. It is a vast concept in which you can work for. And as you can see in my slide, there are several subjects, and that is technology. You can see math making, physics, universe, culture, nature. But as we are talking about space and all, I am focusing today on the subject of space, and it is a matter of interest because. And so you can see, as Gaurav sir has told, it is means there are several citizen science groups all over the world which guide the students, because means when I was a student of class 5 or 6, I didn't know what citizen science was actually. So I know what citizen was, means citizen, the term citizen. I knew the term science, but I didn't know what is the role of the means profession when these two terms are get combined. So means basically the means professions or the role of the teams and the team leaders are to motivate the amateurs, or to motivate means the amateurs, means the students, or means persons, those who have the curiosity. As you Gaurav said told, curiosity is the most important thing that we need for progressing in science, and the role of them to guide them and in right path, and to means in several projects. And this citizen science is a citizen science group. It is the most largest citizen science group in India, which is guided by Sobhan Acharya sir, and it is an international team. And Sobhan Acharya sir, means if you join this group, Shobhan Acharya sir is a very helpful person, and he guides a lot. Means when I didn't know about means any project, and from that stage he has uplifted me to this stage where I'm speaking, and so. And 2 years before, I have made my own team, which is a sub branch of this SS Citizen Science Lab. That is SS Citizen Science Lab Malda, as Gaurav sir told that I am a boy from Malda. So it is my team which works in several projects, citizen science projects, which we will look into. So see, well, as Gaurav sir told, that there are many platforms to talk for. Okay, so I am talking about the students. Means there are several topics to talk for. Means today the India versus England test match is going on. They can talk for with that. But why we are talking about space? What is the need of that? So basically, that Gaurav sir has told that space is the largest observatory, means biggest of laboratory, and it is from there also we can get means images from the observatories. So as you can see, the means the temperature variations I am talking about means one topic, that is temperature variations. That hottest object that we can find in the universe is the quasars, and the coldest object which we can get is the boomerang nebula. So means the temperatures that we can avail in that laboratory, means space, it is not possible for us to means in an ideal case we cannot make that in an artificial laboratory in any part of the world, means in India also, and if US also, means it is possible nowhere. So there is the possibility, means here comes that why we need space, because Sarah's told that from the Apollo missions what can we get, and we know how the means what was the previous condition, means how the solar system or the stars, how they originated and how life came to the universe, and we can means understand, we can research that from the night sky only, because you see the stars that we are seeing, the stars that in the night sky, the stars are means that we are seeing is not the current, means how the stars looks like now. Means the light which we are coming, the star may be means means light several light years means far away from us. So it is means it is telling how that the means past condition was, that means so we can get a clear view that how life originated, or means we can get as a source to research for how life originated in our earth. So coming to the citizen science projects, you see there are many topics in which the citizen science on space are subdivided on, and one of the main topics is asteroids. Today I will talk on three projects, means three subgroups, which is asteroid hunting and kilonova hunting and galaxy classifications, and I will show you and guide you how we can work for and how we can get the acknowledgement. And so coming to the asteroids, the asteroids are the leftover, means the leftovers rocky and the metallic fragments from the early formation of the solar system, which was approximately 4.6 billion years ago. And due to some gravitational influences of the Mars and Jupiter, the strong gravitational influences, they could not get merged into a planet or a means huge structure. So it is means there is a main belt. There is a belt in which they are spread. There is a fixed belt between the Mars and Jupiter, which is known as the asteroid belt. You can see this is the main belt asteroids you can see between Mars and Jupiter. And you can see there are not means asteroids in this asteroid belt only. There are some asteroids also in the Trojans that you can see in the belt of Jupiter. In the orbit of Jupiter, some green spots you can see. There are the Trojans which share their orbit with the Jupiter. And we are also having some near Earth asteroids, means those who are means the asteroids. Some asteroids are there, means who has a fixed does not have the fixed orbit. Means while revolving, they suddenly gets means attracted by our Earth's gravitational pull, and they gets merged into the orbit of the Earth. So there are the near Earth asteroids, and in the last, I think on 21st or 22nd of June, we had a webinar on with propagation only. I was a guest speaker with Vikrant Gurmude sir, where I told that means what are the negative and the positive impacts of asteroid, means how can they affect them and how can we do to means stop them and to protect them. And Gourav sir also told means several points on that. So coming to the point means which we can detect them and we can stop them from means coming by detecting is that by locating them first step. So the first project which I will talk about is the IASC asteroid search campaign, which Gaurav sir has reflected some life briefly upon that. So I will mostly, I will talk about how we can do that project and how we can means get detections and how to do the project and how to get means certificates and all. And certificates means these are the later parts. Means after doing that you will generally get the certificates. So don't run for certificates. Run for the detections. Obviously certificates will come to you. So don't go for it. So basically, this is the IASC logo, which is the IASC stands for the International Astronomical Search Collaboration. And he is the person you can see on the screen, Sir Patrick Miller, who is the director of IASC. And Dr. Patrick Miller is a professor of mathematics at the Hardin Simmons University, Texas, USA. He founded the International Astronomical Search Collaboration, which I told that IASC, in 2006. After he and one of his students took the initiative to do something for outreach and informal education in astronomy. So basically, he is the person behind this project. And this project means speaking some informations, important informations, that this project is a team-based project. Hence, you have to join a team. Like I told that we are working in this project with a team as a citizen science group, I told. But you can also means do it personally as a person, means in the single individual. But it is better to do with a team because it's a team project, and it is a monthly project, means it occurs in a duration of 1 month, 20 days or something like that. And in this project, I think the only project that I am doing, it is the only project that we have to do with the help of a desktop. Okay, so we have to need a desktop or a laptop, and we need a stable internet connection. So as you know, means there are several projects, citizen science projects. Means there are, I will talk about some projects later words which you can do in the smartphones. And so I will now talk about how we can do, because some persons might think, means how can we do this is so difficult, means they can't imagine. At first when I joined, I also at first when I saw the slides, I could not also understand what is this, I wondered. So basically, at first, to prosper in this field or to make detections in this field, you need to have a curiosity and a keen interest in this astronomical field. And as Gaurav said, told, there are no age limit, no profession limit, means no professions, and you can join these projects. And basically, this is the home page of this ISC asteroid search campaign. And this is a project in which you have to download one setup named Astrometrica. It is a software which you can download from here only, means the home page. You can see here a link is there, blue colored Astrometrica setup. When you will click that, means after going to the home page, you will click that, the setup will get installed in your computer system. So here are some basic informations and what is means bio of the Astrometrica software. So if you are interested, you can surely go and search for it. And you can see it means a file will get loaded after the successful completion of the download. A file will get loaded in your means the folders, and from that, beside that also a small icon, blue colored icon will come in your desktop. So after clicking the icon, double clicking the icon, the blue colored icon, you will uh, move into this, that means white colored screen. This is the space, white space in which we do the campaign, I means detections, and we look for the slides. And after the means this space is loaded, you can see we will move again to the means IISc homepage. As I told you before that this project is a group project, and for every campaign you will have a team leader. So your team leader will give you a password and an email through which you have to join. And you will also means this project, you are joining for a team, and so the team leader will, so you can see there are some details of the ISC campaign. The participants all over the world, means you can see those who are participating in these projects. So at first, there are certain means campaigns, which is means under which several teams are there. So I means my group works under the campaign named with Shaptarshi India as a citizen science group, asteroid search campaign. And there are many campaigns, means like 70 to 80 campaigns are there. And under each campaign, there are multiple teams, multiple groups of citizen scientists. So as you can see, here is my group, as a Citizen Science Lab Malda, on behalf of India. So as you will click on your team, means the slides which we'll look for get, means a list of the slides get opened. So the slides which are coming to us means they are captured by the Pan-STARRS 1 and the Pan-STARRS 2 telescope, which is situated at the Hawaii Island. So the slides which will come will be given, means given by your team leader, means which slides you have to look for. So after, when you will, you can see this is my team page, and when you will download the slides, you can see these slides will get downloaded in your folder as a zip file. So to run that, you have to first extract it to an ordinary file, means you can see folder. So in the third option, it is there that extract to PS1 2025. So after right clicking the zip file, you have to click on that so that it gets converted. And again, you can see each slide consists of 4 images. There's image 1, image 2, image 3, and image 4. Those have taken, those means the slides, you can see 40 slides are there. So these slides are taken of, means at in several, means at an interval of time, specific time interval. So again, we will move back to this astrometric of white space where you have to do. So now in the left hand top corner, you can see the file option is there, and you can see the first option which is there, the means the drop down list appears, and the first option which appears is the load images option. So clicking the load images option, it will some slides will come, the 4 slides that we talk about. At first you have to simultaneously, means one by one you have to take all the slides in the screen. And I will try to show you one thing, because as this project is not done in, means in mobile phone, so it is not possible for me to show live. So at first you can see the above ribbon is there. So when the slides will come in this screen, at first the first step which you need to do is the fourth option from the fifth option from the left, the green colored option. That is the astrometric data reduction. And after that astrometric data reduction is successfully done, you have to click this option, means the red and black colored options, which you can see it is not prominent, I think, but I can't do otherwise. The name of that option is known object overlay, means it will show that if any object was previously detected on that particular slide by any other citizen scientists or not. So after that, you means, as I told, that 4 slides will appear on the screen. You have to run the 4 slides, and you can see this option. This option, the name of this option is blink current images, and you have to click that on that option, blink current images, so that the 4 slides get simultaneously run. So after that, for your desire, means for your beneficial, you can benefit, you can zoom in or zoom in the slides for your detection purpose, and you see, coming to the main point of detection, how will you detect any object or unknown object in the slide? At first, means before starting in this means classifying, you have to make a point clear in your mind that in not in every slide we will get an unknown object. This is the first point. Means it is very rare chance. It is a chancy affair to find any unknown object, because you can see I am doing this project for rocks 3 to 4 years, and in this total time period, I have only got three or four preliminary detections. So it is not that you will in every slide you will see it and every slide you will get images. So it is a matter of means concentration, and you have to focus on this, and so that in a long term you can get means detections. So basically, coming to the point, when the 4 slides will get simultaneously run, you can might get some certain images, means certain objects in black colored or white colored objects, means in which in mode you are doing. So I personally do in the black and white modes when where the objects are black in color. So some means you might get an object in which will appear to change its position. Means if we consider it the position of the object in slide 1 to be x1, and the rest as x1, x2, x3, and x4. So the means the position of the 4 images, means objects x1, x2, x3, and x4 will be different. Means the object will seem jumping from one slide to another. Means from slide, means it may be that from slide 1 to slide 2, the object has jumped to the left and it is going left onwards, and it may be in any direction. So when you get this type of objects, means there is a chance that it is an unknown object, and further it may be an asteroid. So the first criteria, means there are several criteria that means the ISC camp have given to us. So we have to first check the criteria, and after that we can classify. The first criteria, means which is the most important criteria, is the SNR. Means when we will stop clicking, means we will click on that object in any of the slides, or when we will right click the object, you can see this box. You can see box like structure, it will open. Okay, so you can see there is an option SNR. The full form of SNR is signal to noise ratio, and it is said that if it is more than 4.5 or 5, you can classify it as, means you can name it as an unknown object, and you can send them for, means send to the organization for searching, looking into further research. And coming to the next point, that how you can name, means basically you have to send a code name on the basis of which the detections will come. So here you can see that is K00A06 is there. Means in that place you can means write the name. Means when I told that the team leader will give you the slides, he will also give you certain codes, means 5 to 6 codes that you can give if you find any asteroid, means means near earth objects, unknown objects. After that you have to accept, and you have to do that in simultaneously in the 4 slides, as you can see. After that, after the total slide You have means completely observed the total slide and everything is done. You have classified everything. The next main step is to download the the MPC report, and it is one of the most important part of this project. And how to draw means download the MPC report or the Minor Planet Center report. I am coming to the back. You can see. I will again click the file option, and you can see uh, below the load flat field, there is view MPC report file. This option is not means activated because there were not slides. But after your class means after your observation will be over, I mean, automatically the option will get activated, and a slide screen will appear where you can see like this, and this report will appear. So you have to copy this report totally, and there will be a space, and even again I will go back to the ISC homepage. In your team page, there will be a space where you need to paste this report, and you will click the desired slide name and all the citizen scientists name, those who have participated, and you have to click the submit option. And after that, one of the most important tasks that means many persons gets to forget is in again we will come to the means the astrometrica software. You will clear out all the slides, and after that again at the last you will go back, you will click the file, the same drop down list will appear, and you can see above the reload mcporb there is an option reset files. It is an important means uh, segment you have to do. You have to it is a mandatory, because if you don't do it, it will may create any obstacle for means glitches for the other team members who will join means and classify means look for the near earth objects. So after your submission is over, you can see after you have submitted this MPC report successfully, a message will get generated, and after means a period of 5 to 7 days, means the report a report will be published by the ISC authority. It mainly get published from means I am doing that from last 3 to 4 years. The report is getting published on Thursday midnight actually. So on Thursday midnight, a report is generated from their side, and they are means I'm showing. You can see if there is any detection, if your team has made any detection, so they will show that, and you can see it is our last detection. You can see, as I told, that a code is required for them means to detect research further research. See here it is there SSC 6251, a code name, and the last my means latest detection was done on I think on March by it was a team of Vikrant sir, and Gaurav sir has also mentioned the name of Hugo Durantini Luca sir, renowned citizen scientist from Argentina, and I was also there. And basically this detection, the preliminary detection which is done, it is means after seeing this detection, you can't tell that it is an asteroid. Okay. So this preliminary detection which is done basically gives us the surety that yes, this is an unknown object which is near the Earth. But it does not give us the surety or the complete 100% chance that it is an asteroid. Okay. So what means there are several criterias they are there, which means which are on the hands of the professional researchers. He means they will search means look into the objects, and they will look into the object for more means 1 year or 2 year, and if it is means they see that the objects are still then they are following the criterias, and then they will mark those preliminary means detections which are preliminary. They will make that preliminary detections as provisional. We can see this is chapter India Citizen Science Group Asteroid Search Campaigns means means four preliminary detections become provisional in the meantime of May 23 of June 27 2025. And the detection report which gets generated. It means you can easily avail the report in from the ISC homepage, but there are lots and lots of asteroids. So basically, if you are curious that if that any detections are made from our team or not, and if you're excited, super excited to know that it is there or not, for your relief, I am saying that the report that any object is means discovered from your team or not gets means the report are mailed to the team leaders, and which you can surely look into and you can see. And after 7 to 8 years, if the scientists look for the slides, means and if the objects the objects provisional discoveries are still maintaining those criteria, they will give us a chance to name those as a asteroid, and we can name. So these are the certificates, preliminary certificates that you can see, and these are the provisional ones that I got: 2022 SM93 and 2022 SQ91. These two provisional discoveries. And you see, as I told about IASC, this is not a platform or not only a platform for citizen science. As Gaurav said, told, Zooniverse, one of the largest platforms in the field of citizen science, is a huge platform, and it provides several citizen science projects, not only in the field of space, but also that Gaurav sir shared on medicine, literature, physics, and climate weather, and several means topics. And for their excellent work, the White House Office of Science and Technology Policy, it is a moment of means happiness, and means it is a glad moment for us that the White House Office of Science and Technology Policy has organized a Year of Open Science Recognition Challenge in the year of 2023. And you will be surprised and amazed to know that this platform named Zooniverse, with the partnership of NASA, received the White House Open Science Award for their excellent works. So, there are many, as I told, there are currently 31 active projects. And so the first project with which I will talk about is the name of the project is Active Asteroids. So means I will show you this project. And this project, the one amazing fact about this project and the race projects which will I talk about is that these projects can be done with the help of mobile phone. So those don't have any computer, laptop, don't worry. You can't do one project, but you have hundreds of options open for you. And Active Asteroids project is one of the project which is asteroid hunting project, and you can surely go on. And I will try to show this project and how to classify this project. Okay, directly from the site, Active Asteroid site. Just give me a minute. Yes, you see, this is the home page of the Active Asteroids project. And don't means you can have on the above, there is a link. You can take the screenshot, or if you don't take the screenshot, at the last, means before the end of the session, at my last slide, I will share all the the links of the projects that I will talk about now. 5 to 6 projects I will share. So these active asteroids examine images to find comet-like tails on asteroids. These strange objects hold clues about water on Earth, in the solar system, and beyond. Moving to the field of classification, means this universe platform, this it is a very good opportunity for the amateurs, because it does not means only give the slides and tell you to do the and classify the slides. It gives the total tutorial how to do, means from step 1 to last step how to do. And if you are still having the doubts, you can go on and look for the field guide and clear your doubts. So when you will look for the tutorial, you can see, welcome, solar system bodies like asteroids or comets are considered active when they display a tail or a cloud of dust and gas. Active objects tell us where ices are found throughout the solar system and even provide clues about the origin of water here on Earth. And there are many tutorials. I'm skipping this because you can see this is a tail-like structure and this is a comma on the basis of which you can do. Let's get started. See, at the first image which we can get is we cannot see, means there is a green colored crosshair, and in that crosshair we can't see any the object which is there. We can't see tail or dust cloud, because in the task you can see there is a question: do you see comet-like activity such as a tail or dust cloud coming from an object? Because it is not there, and so we'll click on no, and we will click done, and like that we will do. And like that, if you we will do continue on, and if you are, because it is not possible for me to show, means classify and many slides, so if you are having more doubt, you can go on with the field guide. There means very good field guides are there which will guide you in this project. And basically like that, ISC campaign also, this projects means we can also get the acknowledgement from there after detection. So you can see it's mere time. As you can see here, the volunteers, those who have classified, their names are there. As you can see here, Ashok Ghosh sir's name is there, a renowned citizen scientist from Howrah, India. And here, Cledison Marcos da Silva sir's name is also there from Brazil. So you can also get acknowledgement from this project. And like this project only, like the Active Asteroids project, there is a new project which is means introduced in this Zuniverse platform, is the Rubin Comet Catches project. This, I'll give me some, yeah. So this Rubin Comet Catches project is a new project, you know. So it has been introduced in the Zuniverse platform in on the last International Asteroid Day, that is 30th June. So recently we have got the largest observatory that we told, the Rubin Observatory. It is in Chile. So it is one of the same process you have to do in this project. As you know, I am running short of time, so uh, I can't show because this project is same as the Active Asteroids project. So now moving on to the next project, you can see I have talked about the Vera C. Rubin Observatory. Moving to the next two projects, that is the kilonova seekers and the supernova hunters. You know, the kilonova and the supernovas are one of the interesting means celestial objects in our night sky, because means in our space, because a supernova is the explosive death of a massive star, while you know a kilonova is a luminous event caused by the merger of two neutron stars. As you can see on the left hand side, kilonova is there. Picture is there. Supernova is far brighter than the kilonova, as you can see. The right hand side of the supernova is flanked by a telescope, but the left hand side is not a real one. So you can see. So the two means projects that are available in the Zuniverse platform are the kilonova seekers and the supernova hunters. The supernova hunters is not active means currently, so we'll look for the kilonova seekers project. Yeah, you can see this is the home page of the kilonova seekers project, and find cosmic explosions in real time with the gravitational wave optical transient observer, which is GOTO. And again, moving to the classification, he will be given several tutorials. As you can see, there will be given three slides. The middle slide will be the reference slide, the left hand the science slide, and the right hand side the reference slide. In a nutshell, I will tell you that the slide which is there in the center, it is a slide of a particular means you can see area in the night sky, means space, which is taken 7 to 12 years before. And the left hand side image, which is their science image slide, means it is the image of the same area, means which was taken 2 or 3 nights beforehand. So, and the third, that is the right hand mode side, there the difference slide. It shows you that what is the main difference, means what is there any difference or not between the area in the last 7 to 12 years. So after reading the tutorials, you will get means click on get started. And here it is told that is there a real detection center in the science and difference image crosshairs. So basically, if we look in the difference image, there is no difference, means between the last 7 to 12 years, no difference is caused. So we will click on no and done. And here we can see a slide. You can see in the science slide at the center of the crosshair, a small white color dot is there. And in the reference slide, it is not there. So we can do is as a real detection. Click on yes and done. Same as the active asteroids or the Rubin comet catchers, the Zooniverse has given you the field guide in which you can see on the topics in detail and you can classify. And after classifying, you can see you can also get results. Means the results will be published that it is, means any kilonova means is detected or not. So coming back again to my slide. You can see here, this is how the means acknowledgement is given. At first, you can see Ladies and Marcos da Silva sir's name is there. And at last, my name, Shourjya Pal, is Vikrant, along with Vikrant Kulmuje sir, Ashok Ghosh sir is also there. So as I told you about the Supernova Hunters project, this project is not activated now, means currently, but I participated in that project means 3 years before, and this is how it is also an interesting project, and almost you can say it is similar to that of the kilonova uh, seekers. And so here also you will get the discovery certificate. In the remarks section, you can see this transient was discovered with the help of citizen science project Supernova Hunters run by Zooniverse. The candidate was identified by volunteers including Ashok Ghosh, Shourjya Pal, and Giovanni Colombo. Means if you have detected this transient, your name will be published. If you if you have detected it among the first 3 scientists, your name will be there. And so coming to the third and the most, is one of the most interesting citizen science projects. Gaurav said also reflected some light and told about the Pune Knowledge Clusters project, that is the galaxy classification project. As you know, the galaxies which were there, massive gravitationally bound system consisting of stars, stellar remnants, gas, dust, and dark matter. And so I will move to please give me a minute since the page is loaded. It is the home page of the National Astronomical Observatory of Japan, NAOJ, which it is an organization which organizes this project throughout the year, and I think it's taking some time. So please give me a minute. Yes, so the page has come. So this is the homepage of the Galaxy Cruise project. It is a citizen science project which is run by the National Astronomical Observatory of Japan, NAOJ. And here you can classify the galaxies on the basis of their shapes. Means, the most three prominent shapes in which the galaxies can be subdivided into the spiral and elliptical and irregular on the basis of their shape. And you have to classify with that only. And so this means the galaxies I'm showing you. At first, for doing this project, you have to make an account. I will show you in detail. So, as an amateur, if you don't know that how to classify the galaxies, so it is for you, I'm sure. I think I don't know why this page, the Nouch page, is taking so much time to get downloaded. All the slides, you know. Yeah. So, which is there? The lesson one. Start by practicing how to distinguish the basic shapes, which I told. This is the participation procedure, which will let you know that how to classify and how to move on with this project. And at first, I told that there are means well classification. There will be two stages. The first stage, which will be there to classify the galaxies into the elliptical galaxy and means and spirals and the ellipticals means on the shapes. So, starting the tutorial. Means the galaxies, the mostly all the galaxies means if you group them, mostly the galaxies are spiral in nature because of their spiral arms, and the elliptical galaxies are named for their ellipse shapes and like that. So here you can see the lessons are given. There are two type of galaxies, as I told, round elliptical galaxies like rugby balls. They have also given the images, and disc-shaped spiral galaxies like pancakes. These elliptical galaxies and the images of the galaxies, which we can see, are taken from the Great Subaru Telescope. And you know, the spiral arms and the round shape will at first let you know that it is an elliptical galaxy, a spiral arm. The first slide in the tutorial, you can see that the object is having a spiral arm. So, with no doubt and hesitation, it is a spiral galaxy. And second one is that it is an ellipse shapes because you can see means prominently that there are no arms and it is ellipse shapes. So it can just put on the elliptical galaxy. And like that, I don't have any time, so more time. So moving to the lesson two, where after means after the first detection, first stage is over. That is, you have classified that means the galaxy is an elliptical galaxy or not, or an active means spiral galaxy or not. So the next step which will be there is to classify the galaxy on the basis of their interaction. Means is the galaxy interacting with any other galaxy or not? So let's wait for the training session 2, intermediate session. You can see some galaxies are interacting through their mutual gravity, affecting their shapes, and these galaxies are called interacting galaxies. You can see clearly they have shown the partially pulled out galaxies and the distorted one. So the first question which is there, is this galaxy interacting? So obviously, yes, you can see it is means you can see partially pulled out and partially distorted on several directions. So you can see that yes, it is interacting, and after that, it will be given with a message of correct. It is correct. So you can clearly see that it is not an interacting galaxy. So click not an interacting galaxy, and this is how we will complete the tutorial, say lesson 2. And the last lesson means before you will move on to the galaxy cruise, the last lesson which you have to means look for is the lesson in which you have to classify the means galaxies on the basis of their further modes. Means there are subdivisions of their interactions, like they are like fans or ring shaped or get distorted with any other galaxy or having tails. So yeah, you can see the following 4 types of features can be found in interacting galaxies. The first one is rings. You can see the concentric rings are there. I think it is visible. And the second one is shells, or it is nicknamed as fans. You can see because it's fan-like structure, And the third one, and which is there, it is named tidal stream, or nicknamed as tails. You can see pulled out feature from a galaxy. And the last one is distorted halo or distortion, and which is an asymmetrical structure. Is you can see this distortion is means it is caused because of the gravitational pull of the neighbored galaxy. You can see on the image distortion of image. Let me show. On the right hand side of the image, there is one small galaxy which gravitational pull is influencing the large galaxy to get distorted. And so there are 4 modes of interacting galaxy. And here it is first means the first from we will do from this first stage. Here it is telling it is an elliptical galaxy, spiral galaxy, or neither galaxy. You can see that it is not a spiral galaxy. You can means you can eliminate it because is not having any spiral arms. And it is also not an elliptical galaxy like because it does not follow a complete ellipse shape. So I think this is neither. Yeah, it is a neither case. And what features do you see? Means, is there any interacting features? You can see that this image is like a ring. You can see a ring-like structure, center ring, the jewel at the center of the ring. You can see. So it is a ring-like structure, and after that, you have to complete the total tutorial like the above mentioned guides, and after you will complete all the training sessions, you will click on I have completed all the training sessions, and a boarding pass will be loaded to you. And through the boarding pass, you can get on the Galaxy Cruise project, the mainstream. This now the National Astronomical Observatory of Japan. This organization holds 2 special means campaigns throughout the year. One summer campaign and one winter campaign. The summer campaign and the winter campaign mostly takes place. The summer one in June or July, and the winter one in January, mid January to February. So, and in those campaigns, you have to classify the required number of galaxies given by them. For your information, and for your information, I will tell that in this year, there in the winter campaign, the required number was 2025 because this year was 2025 indeed. So the persons, those who have classified the required means number of galaxies, means the first stage is there, which is the classification of above 1,000 galaxies, and the second classification is made on above 2025. A report is made and report is published by the NAUJ. I am downloading the report. It was generated by the National Astronomical Observatory of Japan, NAUJ, on after completion of this campaign. But if in the meantime of this campaign, the general classification goes on throughout the year. So those who are interested, you can just log in, make an account, do the tutorials, and then classify at any time. So you can after the campaigns, the citizen scientists, those who have classified more than 1,000 and 2025 galaxies, their names are there. And we have many citizen scientists from India. That is Vikrant sir, Shobhanacharya sir is there, Aditya Pawar sir is there, and Rudra Pratap Datta is there, Shanchan is there, my name is also there. And along with several other citizen scientists. And if you are lucky enough, means after the successful completion of these projects, the NAUJ, the National Astronomical Observatory of Japan, means this is a Subaru telescope, as I told, through which we get the images of the galaxies. And after the campaigns, we conduct certain lotteries. And if your luck is good, you will get a calendar, a very fascinating astro calendar filled with great images of the galaxies and several stellar astronomical objects. And they will send you a greetings card. And it is a means very fascinating, um, thing is means a special object is coming in female means from far away Japan. It's a very good feeling. So I have means participated in this project for the last 3 years, and for the last I don't know that my luck is good, so that my for the last 3 years, consecutive last 3 years, I have got these calendars and greetings card. So if you get it, it will be means it is a matter of happiness. And if you don't get it, it means you not need to get sad, and you can go on with the further classifications, because the main thing is there. Your name is there on this website with all other citizen scientists of the world. And so the last means the project, which it is a matter of pride that an Indian organization, that is the Pune Knowledge Cluster, that office of which is the principal scientific advisor to the government of India, they conduct one event named the 1 Million Galaxies event. So I participated in that event in 2024. So let me give you. I think the project is not going on now, but this is the home page of the Pune Knowledge Cluster (PKC), and here you can see 1 million galaxies. The advertisement is there, and the participate option is also there. So you can just go on and participate like that as you have done in Nauch, and there the criteria will also be there, and they will guide you nicely to classify all the galaxies. And along with these two projects that I have told in Galaxy Classification, Nouge, and this one Pune Knowledge Cluster, there is also one interesting project in the Zooniverse platform, that is the Galaxy Zoo project, which you can surely classify. And at last, as I promised before, I have given the links of the above discussed citizen science projects, and those who are interested in the platforms in doing this projects and classifying some detections, you can just take the screenshot, and you can means in the future you can go on with these projects, because these projects are very interesting projects. And when you will enter these projects means uh, it is means when you will enter this project, and you get lost into the vast universe, and your brain means your mind will means tell you to do more and more with this, and to go more and more with this projects. So you can take, I am holding on in the slide for 10 to 12 seconds more. I think it will be enough in the meantime to take a screenshot. Okay. So, as we come at the end of the session, I will tell you one thing, that the 5 to 6 projects, or the 7 projects about which I talked about, or about which I explained to you, these are not only the projects that you can do in this citizen science platform on the space segment. There are hundreds of projects that you can do that are open to all, and you can just go on, and with your keen interest, you can classmates go on with all that projects. And this is a time bounded session, so I can't show you more than these projects. So if you have keen curiosity, you can go on with the projects that I have mentioned, and many other projects. So this is for all, and I thank you everyone for lending me your ears to listen to me, a student of class 9. And if I meet you again, I will talk about the other projects, several other projects on this platform. And I just pay my thanks again to Propagation and Social Citizen Science Group, and of course to Gaurav sir for organizing the session and giving such a beautiful opportunity for me to speak. So thank you everyone. Have a nice day.
All right. This was great. This was absolutely wonderful. Oh my God, a lot of information, a lot of stuff. I will say that please do not worry. Everything will be provided to you in the doc that will be given to you. Everything related from all the links that are shared here, all the resources, all the projects that Sean himself showed to us. Everything will be given to you. A few general things. Uh, the doubts that were told in chat regarding Yogesh Malviya and Komal Mehta, all these people will be answered. If they can email their specific doubts, we can answer them directly as well. And some general doubts like how do astronomers identify special celestial objects through observations? I think Sean has given a very, very specific answers to all these. He has told us a lot of instruments,
Okay.
a lot of projects.
Okay,
Again,
we are just going to call our speaker who are just going to answer all the doubts. If you
Yeah.
are having any doubt, you can discuss everything. Okay,
Yeah.
you can turn on your mic also. I'll just respectfully, I'll just call our speaker to answer them.
Mr. Gaurav,
Please.
yeah.
Yeah.
So,
I hope I am audible. Yeah.
Yes, God bless.
So yeah. So first of all, yeah, wonderful talk. Shourjya, I was also following that. So I guess you have also mentioned very well some of the points. So there is a question which has been put on by, I guess, Yogesh Malviya ji. As far as we look in the universe, we look at our past. So we are unable to see what is going on far in our universe, and we cannot predict how big our universe really is. So basically, is there any way to know that we can calculate or know how big is the universe and what is happening at the edge of the universe? So this is a good question, curious question, Yogesh ji. Yes, definitely there are ways. So ये हम लोग तो in professional astronomy there are certain techniques, methods. Now, if you आप अगर cosmology, that the subject which deals, or the area which deals with the origin and evolution of the universe as a whole, that area is known as cosmology. There are certain ways by which through cosmological studies हम लोगों को पता है how big is the universe, but it is so big. Basically, the next part of your question is more curious, whether the age of the universe. Our universe is such a fascinating entity कि most probably there is no age. If someone of us have some superpower, और अगर हम लोग सुपर पावर के साथ लाइक अ सुपरमैन हम लोग अगर ट्रैवल कर सकते हैं, तो जितना भी सुपर पावर हम लोग के पास है, हम लोग कभी भी एज ऑफ द यूनिवर्स तक पहुंच ही नहीं पाएंगे. मतलब ऐसा नहीं है. इट्स नॉट लाइक अ बॉल कि it's not like a football ki one ant is going on. It's like that, one ant is going on, and that football, whether that ant will find an age, it's difficult to predict. But ऐसा कोई जगह है ही नहीं कि ant उस फुटबॉल के ऊपर से गिर जाएगा. That is possible from a football, but from universe that is not possible. So basically there is certainly, most probably there is no age. At least we have no idea. Till now, our cosmology, wonderful and very well explanative cosmology, tells us how big is our universe, what is its age. Age means age, uska umar kitna hai, but not where it is ending. That is not the case actually. See, and it is also expanding. But how much we can see, maximum we can see up to that limit from where light has traveled to us. So that observable universe limit is 13.8 billion years at any site. So 13.8 billion years plus 13.8, around 27 billion years is the diameter of the universe. But that is observable. But if we consider all other aspects, right from the beginning of the universe, its expansion in a dramatic way, in an erratic way before, and now gradually in a more understandable way, then most probably the whole diameter of the universe spreads much more than 90,000, 90 billion years. It's 90 into 100 crore, 9,000 crore light years, more than that. but that much we cannot see. So our observable limit will be around 13.8 billion years at any one site, maximum from where light can come. So this is the it is another idea of a scientific query, which is another good question, which has been asked by some just now. How do astronomers identify specific celestial objects through observation, especially when many objects appear similar? Are there particular techniques or instruments that help distinguish them? Definitely. Just now, I guess when you have listened to Shourjya's talk, he was explaining some techniques by which we can, even by watching an image, you can classify galaxies, or you can understand whether it is an asteroid candidate or not. So basically, yes, in astronomy, there are definite techniques, very specific, high precise techniques through which we can identify which object is what. And before that, we have to understand, we have to know. That is why astrophysics is a hardcore study, is a proper hardcore study of physics of the celestial objects. So you have to know how a star behaves, you have to know what are the differences of a star and a planet, what is the difference between a planet and a satellite, what are the properties of physics of stars. All these things, if you have in detail idea, then using certain techniques, definitely we can understand. In observational astronomy, majorly we use three techniques. One is photometry, measuring the brightness of some source or object, and from measuring the brightness we can tell so many things very specifically, its distance, its age, its structure, we can tell. Then spectroscopy, taking the spectral features, means passing the light we get from astronomy. In astronomical objects, what we get is light, means radiation. So passing that light or radiation through a spectroscope, we actually generate the spectra, and that spectra is a definite signature. We have spectral signatures of all the components present in that particular object. That tells us about all physical, almost every proper physical property of any celestial object we can understand very precisely by studying spectra of that object. The differentiation of objects, its properties, its evolution, its composition, its structure, its rotation, revolution, everything we can understand up to a certain level by spectroscopy on average. Another thing is that suppose we know that between our stars also it is between stars or between two planets, the space we say it is almost vacant, empty, but it is not absolute zero, absolute void. It is not like that. There are very little amount of gaseous or dusty materials present, which we call as interstellar medium, or between galaxies also we call it as intergalactic medium. So for studying that the material which is present between two stars or two galaxies, we have to use something known as polarimetry. So these are some certain techniques. Also there are astroseismology to understand what is happening inside a star, like sun. There is neutrino physics, neutrino astronomy, to understand how inside the star how energy is generated. Then you have definitely heard about something known as gravitational waves. So new, then multi-wavelength approach. So there are definite techniques by which very precisely we can understand the astronomical events, the astronomical phenomena, their properties, these things. Definitely, it's a good question. Yeah, so I guess we have another question from, Komal Mehta. Hello, sir. I'm from a biology background. Okay, that's good. And I don't know how this citizen science thing works and what are the prerequisites and how it will help me. So please, can you elaborate? Okay, Komal, I guess you have got certain answers from Shourjya's talk already. Yeah, so if you want to join particular biology projects, then you can definitely go to Zooniverse platform, and instead of space or astronomy, you can open the biology section. There is a biology section also, and you can gradually join. And I guess Shourjya has given a wonderful explanation. Suppose for 2-3 projects, example wise, you can join those projects. And apart from that, if you become, suppose, a member of the WhatsApp group, you want some guidance from, you are particularly interested in some particular project and want some guidance, you can get the guidance from that AC Citizen Science WhatsApp group also. So, and how the citizen science platform is working, what are the there is no prerequisite. So I guess I have also told this, Shourjya has also told this. And so there is no prerequisite. Only prerequisite is up to a certain level interest and definitely your seriousness. So basically, you're contributing for science. So up to a certain level, you have to understand whether you are coming to amateur astronomy related contribution, citizen science related contribution, or in future, if you want to become a professional astronomy, hardcore academic researcher, seriousness is absolutely important. Without seriousness, you cannot take it as a joke. It's not a game. Even a game is a serious issue. So you see how the 5th day is going on today. Both the teams, India and England, they are not ready to spend a single loose ball. They're trying to save, and somebody is trying to win India. So this is it's a serious issue. So nobody means here will expect anything extra from any prerequisite is not required, but your interest and your seriousness, that is the only prerequisite. So you are welcome. Definitely you are welcome to the community. And definitely if you want to do some works in biology, then you go to the biology section. You go to the biology section and there are projects related to biology. Okay. Okay, there is a question from Gumnam. Okay, I am a working professional, Gumnam is telling, and would like to dive more into astronomy as my interest, would like to contribute in research papers. Kindly do provide such platforms for research works. Okay, yeah, Gumnam. I will suggest, since you are a working professional, first of all, you can see research paper contribution is a very different ball game. For getting acknowledged or for getting co-authorship in a research paper, you will really need to spend a good amount of time giving some, as I have told, giving some meaningful contribution. So I am not sure whether you will be able to take out that time from your working environment or not, because basically contributing in a research paper is basically mainly done by hardcore professionals. See, I am, my work, my job, my passion, my love, my wife, everything is astronomy. So I can do that. My full time I am devoted to only astronomy. But for others who are working professionals in some other fields, means absolutely dedicating to astronomy and 100% reading about astronomy, only astronomy, astronomy and astronomy, then only you will get to know the very basic concepts first. So extreme in-depth understanding of physics and mathematics is required for ultimately going to a hardcore academic sector and tell that I would like to contribute in research, means as a co-authorship. But as I have shown, that such kind of contributions have also come, and it is increasing, from amateurs, from citizen scientists, even from India. Even we have Shovanacharya ji from our own India, who has co-authorship in more than, I guess, 10 papers. So we have to understand, he is also a working professional, he has his own family. So how much dedication, how much passion, how much, maybe I don't think he sleeps for even 1 hour in a day, because he has to work, he has to take care of the family. After that, whatever time is there, I guess he is only doing astronomy. So that kind of, if you are ready to give that, then only it will be possible that you can contribute for a research paper. Otherwise, you can definitely contribute, suppose asteroid searching. So if your work is good, if you're, first of all, you will get certificate, acknowledgement. But if you are really searching something, finding something which is nice, which is really good, which nobody has seen, then definitely the particular researchers will think or will consider that we should give co-authorship or acknowledgement to this person. So that is possible. But if you absolutely want a serious note that I want to only contribute in research paper, then you have to leave your job, you have to leave that working environment and come to astrophysics research after doing BSc, MSc in physics or astrophysics. There is no other way. Because it will take at least 8 to 10 years of proper formal training to understand basic concepts of physics. After that, research is possible. Proper.
Thank you, sir. Thank you so much.
Now, yeah, that is the case. Also, I don't have any LinkedIn. I have WhatsApp that I can share in the group. Yeah.
Sure, sir. Thank you.
ResearchGate is there. I can share that. I guess some other question is also there. Okay, Darshik is there who wanted to know about career opportunities, the diverse career opportunities in pursuing MSc Physics with Astrophysics courses in institutions like IUCA, okay, or good institutes. Yeah, Darshik, so one point which we have not much highlighted because of time issue, a factor is there. So yeah, I am pursuing that you are suppose in either school or BSc level. So definitely for going to MSc, you need, means, for becoming an astronomer, you have to do MSc in physics, either MSc in physics or astronomy, astrophysics, or you have to come through engineering background. So if you want to do, if you want to become an astronomer dealing with astronomical instruments, so there are options for both people. Okay, I can share my screen for maybe for 2 minutes once more. So I have skipped those career opportunities here, but let me show. Yes. So you see this. So see, for giving MSc in physics and taking admission in some very premium institutes like IITs and all these good places, you have to give this exam, a JAMS exam, and gradually involve yourself in research projects, at least during MSc level. If you want to do MSc in astronomy, astrophysics, there are certain places in India like Osmania University. So it is in Hyderabad, Presidency University in Calcutta, IIT Indore, IIST Trivandrum. Some these are there in India where they have Department of Astronomy and they give, or School of Astrophysics, they give as a master's, very specifically masters in astronomy, astrophysics. So I have mentioned some of the exams which you have to clear for that. And these are all highly demanding subjects because there are many applications. So only the topmost people will be able to get these chances. After that, obviously, PhD is the only option. So there are, apart from these places, there are also some other options, like there are certain number of good private universities which are coming up now, like this is Christ University, Bangalore. Then there are other universities like Manipal University, Manipal. There are different, Delhi University, different other universities who are opening or who have either opened or are opening very frequently. They are opening Department of Astronomy and Astrophysics, Center for Astronomy and Astrophysics. So there are ample amount of universities now in India who are actually giving you MSc Physics with specialization in astrophysics. One is definitely in South India, one of the best is Christ University in Bangalore. So what I will suggest, you can go through internet searching. Means nowadays everything is in our hand. So just type your same query, MSc in Physics with specialization in astrophysics, what to do. You will see ample amount of information is available in the internet. You do your own search. You search and make a list and see where you can fit, where you can go, what type of exams you can give. And for example, if you also want to go to institutes like IIA, IUCA, these are premium institutes. So you can go to this particular website, Joint Entrance Screening Test. So this JEST exam or NET exam, you have to appear for anyone who wants to pursue PhD in astrophysics in premium institutes of India. So if you go to this website, you will see, so this is the exam details for this 2025, but go to this participating institutes, click here. You will see all the institutes, all are extremely premium institutes. And these are mainly devoted to physics and computer science research in India. So all these institutes having a link, you can click here, ARIES, and you can just see, you can see the list of all the institutes which take via JEST exam. So you can click in any institute, you can click, and you can also see which are the institutes who are giving PhD in astronomical physics, astronomy and see TIFR. Now if you want to go to TIFR, just click here. Just click here, go to their detailed website. If you want to go to IIA, just search here IIA, where it is IIA. Like that you have to do. And go and search. This is IIA. Okay, so suppose you go to IIA and see what are the subjects they deal with in broader area. You see Harish Chandra Research Institute, Theoretical Physics and Astrophysics. This is in Allahabad. HBNI, Bose Institute is in Calcutta. It is in Nainital. So they have all mentioned here. So you go to this particular place, participating institutes under GEST. All the premium institutes apart from IIT and NITs, you will get here, who take admission in PhD using GEST exam. Yes, so this is the one way you can go. So you see, this is TIFR. Now you go here, research, physics. So you can go on searching. So what are the departments? Physics at TIFR, astronomy and astrophysics. Go here, search. You see about the department. Who are the people in this department? What type of research is going on? Or is there any career opportunity? What are the major projects they are involved in? Every detail is given here. So nowadays, I will definitely say, if anyone comes and tells me, or anyone, means any of our academicians, ki, sir, I was trying to search, I couldn't become an astronomer because I was not getting proper information. That is not true. That is not true. Everything is available in internet. And also, if you want, you can also have a look into this particular book once. So this is a book. If you forget everything, this is a book where everything is mentioned. This is the first and only guidebook how to become an astronomer, giving all this information, putting together in one book. So this is a small initiative which I took. I wrote this book for this purpose only, to answer this question in a more elaborate way. So this is available in Flipkart and Amazon. You can have a copy of it. So I guess if there are any other questions, one can ask.
Sir,
I
there
think-
is sir, there
I
is a
guess
person, Jatin.
Yeah.
Jatin is having
Oh.
also doubts, sir. Yes.
Okay, there is one question from Prachi just now. Can I get into PhD without entrance? No, Prachi. At present in India, without entrance, PhD in premium subjects like physics, chemistry, math is not possible. Means at least one entrance test you have to clear. And for that, you have to definitely study well. Means it can be an entrance test, national level entrance test like NET, JEST, GATE. That is also possible. If you are coming to, suppose, universities like, Christ University, they can tell that we have our own entrance test. In case of IUCA, they also have their own entrance test, INAT. So if you are not clearing JEST or NET, you are clearing INAT, or you are clearing the entrance test of Christ University, that is also possible. You can join. But I will suggest clearing a national eligibility test is definitely important. Otherwise, you might not get funding. Without funding, doing research is almost impossible. So basically, you have to clear. Means please try to remember, as Newton told, right, to one king, there is no royal road to mathematics. You cannot learn mathematics in a shortcut way. I generally tell, there is no royal road to knowledge. You cannot gain deep knowledge about anything and become a scientist without using shortcuts. Impossible. So you have to, as early as people understands this, it will be beneficial. Okay. Yeah. So yeah, somebody, Jatin, Jatin was asking something. Yeah, please go ahead.
Jatin, just turn on your mic and you can ask. Please go ahead. Jatin?
I don't think so he's here anymore.
Okay. If anyone having any doubt, please turn on your mic and ask.
Okay, there is a question from Piyash. Sir, I am currently pursuing BTech in electrical engineering. I want to go to astrophysics in future with GATE. Where are the institutions best for us to see? Yeah. So Piyash, there is opportunity for engineering students like electrical electronics to join a particular program known as Integrated MTech PhD in Astronomical Instrumentation. So since you are from engineering background, naturally you cannot suddenly join to astrophysics, but your area should be, in that case, you can join astronomical instrumentation, and IIA and ARIES, they have separate systems, separate degrees offered for integrated MTech PhD in astronomical instrumentation. So you can go to IIA website, you will see the details given there. Search it out. Every details is given in IIA and ARIES website about integrated MTech in astronomy and instrumentation. And P.S. Bhattacharya, so you are a Bengali. So basically integrated MTech in astronomical instrumentation from IIA. It is conducted by IIA in collaboration with Calcutta University. So this is a very important stream, and from previous year, पिछले साल से एरीज से भी ये same work होता है. So Aries has also started doing this. So I will try to, if possible, I will try to show the IIA page. Because internet is working slow here today. So, okay, is there any? Okay, somebody is asking, sir, I am P. Sir, I am currently pursuing BSc in physics, want to do MSc in astrophysics. And where can I do it after clearing? If you, P, if you are clearing, if you are doing BSc in physics, you are in 5th position now. So if you are clearing JAMS exam, IIT JAMS, definitely you can go to IITs. And for astronomy, MSc in astronomy, astrophysics, basically at present, there are few IITs where astronomy department is present. The first IIT which opened astronomy related department is IIT Indore. Presently, we have at IIT Kanpur, IIT Tirupati, so also IIT Palakkad in Kerala. These are the IITs at present which are having, they have departments of astronomy. So you just go to this, go to the websites of IITs and you yourself search out. There are more than 20 IITs. You yourself search, you yourself answer your own question. Yeah, because that searching should be become, I know that this should become a mandatory thing for anyone who wants to do good in future in studies. You search it yourself. I am just telling you the answer. Yes, IITs are there. At least 4 IITs are there where astronomy is given. I have also told the name, but you yourself do a modern search. Who knows? I also don't know. Suppose today another IIT is telling that, okay, from tomorrow onwards, we will also give MSc in astronomy. So you yourself search it out. All the IIT websites you go and go to their departments, as I have done, as I have shown for TIFR, to go there. Go there and search and make a note of it. So if you are clear that I want to do MSc in astrophysics from IITs, then your goal is to crack IIT JAMS and get admission in a proper IIT for MSc astrophysics. So that's where you can go, definitely. Yeah.
I think
Okay,
there's a
Prachi.
Yeah.
Prachi has asked one question. I want to pursue PhD. I already have done MSc physics in electronics this year only. Yeah, Prachi, you can go to, so you go to the IIA website, you go to these participating institutes, check all these institutes' details. And there are some options are already there in some institutes where they can also consider you. Since you are MSc in electronics, it will be better if you are doing some, if you are joining the integrated MTech and PhD in astronomical instrumentation course. Also, if you want to do purely MSc, means PhD in astrophysics, that is little bit difficult in Indian context, but you check because basically astronomy is basically becoming more and more bigger in India every day. So you just check, go through these institutes, go through the IITs also. You just check whether any such option is coming up, that you can join PhD in astrophysics after MSc electronics. I hope that is not present. I doubt whether that is present till now. If that is not present, at least in Aries and IIA, TIFR, some places are there. Definitely with MSc, having MSc in electronics, you can join PhD in electronic astronomical instrumentation. You can definitely join. So Aries and IIA has that facility. Just search it. Just make a note of it, basically. So just take it as a homework. So you yourself will become knowledgeable in that case. Yeah. Yes, but for GATE qualified, yeah, definitely. Anybody who is GATE qualified. So for GATE qualified like PS or whoever is GATE qualified, they can also join. Means they can also give interviews in, if you have much better, I guess more than 95 percentile if you have in GATE, then NET, JEST and GATE. Anybody who is qualified UGC NET or JEST or GATE, they all will be called for PhD astrophysics interviews in all those great good institutes, according to your merit, according to your percentile which you have received in GATE. So if you clear the interview, you can join PhD, definitely. Yeah. So just go to these institutes and search this eligibility criteria, what are the, how we can join, what are the eligibility, all will be written here. Just search it out. Yeah. Do the homework.
All right, so I think everybody has these kind of questions. These can be cleared in the general channel of WhatsApp as well, and you can search it out as well, like so said. I think this is about the end of the webinar. We have a few announcements to make. People who want to, like, people who are writers and want to write about something like that, they can write blogs for us. We have about 1K or 2K visitors every I think day now. So we are growing in that kind of numbers. So people who wish to write blogs or have some sort of knowledge that they want to share with the world, they can write it in our propagation website as well. We have our blogs channel. They can write it there. And especially people who want the certificates, please fill out the forms. We were a bit late last time providing the certificates, but this time it would be much faster and a much streamlined way. We'll provide you the certificates directly in the propagation website itself. And we want to thank all of the people who are involved, especially the two very great mentors. And about this, I think Yash, Jitendra wants to say something. Please go ahead.
Okay, everyone. So I just want to announce one thing. If many of the people having doubt regarding the contact details of speakers, so just join our community, WhatsApp community. There we are just going to provide you everything, like the notes of today's workshop and the contact details of our speaker also. Okay, and in more detail, like contact details of SS Citizen Science Group also. So that's all for today. This workshop. I just request you all to turn on your camera so we could capture.
There is one more question. Yeah.
Yes, sir.
Yes, sir.
Yeah, so there is one more question coming from Asha, which is a very pertinent question. Just I will take 1 minute. Asha has asked, sir, can I submit a citizen science project as a MSc project? So it's a very pertinent, nice question, Asha. You have to talk to your particular college. It is dependent on the college or the university or your department of physics, the department of engineers. So if they are allowing you to do that, then you can definitely do. No problem in that. Yeah. So, and please understand, see, so if you see Shourjya is in class 9, and you suppose you are in MSc physics. So if Shourjya is submitting a project, and that is our wonderful project, suppose on asteroid search, what work he has done, if you submit the similar kind of work as an MSc project, that might not, that should not happen. Yeah. So we should consider Shourjya as a school student, what he can do, he is doing. But if you want to submit an MSc project as a citizen science project as an MSc project, then that should have that level. So if that you can do yourself, if you can manage that, that you have to understand. If I have already shown you some images, the class 4-5 students are also doing good works. So if you also do the same work and tell this is my MSc project, then the university or the HOD physics, they might not accept in any college of India. Because they will tell you, then what is then we can take Shourjya also in MSc physics directly. Then why he should pass through 10, 11, 12, BSc? Not necessary, right? So that you have to confirm. Your MSc project becomes a MSc level project. But you can take the help of citizen science, definitely, if your department and your college is allowing you. There is no harm in it. Yeah. So good question, really good question. Yes. Yeah. Thank you everyone.
Like turn your cameras, everyone. Turn on your cameras. We can just take a quick pic and we'll let you all go.
And in the last, I would just like to say thank you so much to the Swan Acharya sir, who is still in this. If sir, I would like to ask you to speak something. If you are interested, please go ahead, because you are very big inspiration for everyone. Just go ahead, first, sir. You are not audible, sir. Just unmute yourself. Audible.
And interested can participate. student science project from anywhere, anytime, with the help of a desktop, laptop, even mobile phone also. One of my favorite projects is Supernova Hunter. That is a detection by more than 1,000. But I have one mobile phone, 7 years old. With that, I am detecting more than 500 out of 1,000. So in this way, anyone can put it. Only interest is required. There is a lot of scope, asteroids, exoplanet hunting, variable star, even exo-asteroids, bound dwarf. There is a lot of projects.
Thank you so much, sir. Let me summarize. Let me tell you something about Swanacharya, sir. Sir is from civil engineering background, but he had done lots of things. Please, I'm just going to provide the SS Citizen Science group. Just go and join that. It's really amazing group. There you'll be going to meet lots of people, the researcher and the people like that. And please contact Swanacharya, sir. He's a very fascinating person. Everyone just turn on your camera so we could capture this amazing moment. Everyone, I request you all to turn on your camera. Okay, thank you so much, everyone, for joining us.
Thank
Okay,
you.
just before ending, there is
Yes.
a very good question from just now. I noticed the best question I will suggest. So Tejas, I guess Tejas should be given one clap. Means Tejas, sir, is astrophysics a well-paying field? How much is the salary? The best question has been asked by Tejas.
Yes.
Yeah, so yes, Tejas, my friend, it is a well-paying field. But if you can become a faculty, if you can become a scientist at some premium institutes, as we are telling IIA, IUCA, all these IITs, NITs, so or you can become a professor, academician, faculty at some premium universities, even private universities. Definitely, it is a well-paying field. Yeah, so this is your yes, it is a well-paying field. Yeah. Okay.
All right. Thank you, everybody. Thank you so much. Thank you so much for doing this. Thank you, especially to
Thank
sir.
you.
Thank you so much. Thank you
Thank
so
you.
much, Harry, sir.